Hello everyone, I welcome you again to the learning. In this video, I have described inductive effect, fundamentals of inductive effect, plus I and minus I effect, and various applications of inductive effects like predicting the acidic strength of carboxylic acid, deciding IR absorption of different bands depending upon electron releasing or withdrawing group attached to it, and in deciding basic strength of amines. So these applications I have described in this video. So what is inductive effect is, before that I would like to make you recall something we have discussed in the video where we have learned about electronegativity, and in electronegativity we have learned that some element have got tendency to pull bonded electrons towards themselves, and this tendency is based upon their atomic number and atomic size. So those elements which are there on extreme right side of the periodic table are electronegative, whereas those metallic elements which are there on extreme left of the periodic table, they are electropositive as compared to other elements. Now we'll see how this concept is useful in understanding inductive effect. Say for example, we will discuss about a CH bond and CX bond, that is a bond between carbon and halogen, maybe chlorine, maybe bromine, maybe iodine, or maybe fluorine. So in between carbon and halogen, carbon is electropositive and halogens are electronegative as compared to one another. So halogen will always pull bonded electrons toward themselves. As a consequence of that, they acquire negative charge and carbon acquires positive charge. So bond is intact, that's why charges are shown partially, that is delta plus and delta minus respectively. This is called as polarization because poles such as positive pole and negative poles are formed on the carbon and halogen. Alternatively, two different charges are there, so we can call them as a dipole. Now, formation of positive or negative poles or charge is called as polarization. If we think carefully why this polarization occur, reason for this polarization is difference in the electronegativity. Halogens being electronegative, they pull electron and polarization occur. So this process of polarization of bonded atom is called as inductive effect, and which is ultimately due to the difference in electronegativity. So inductive effect is an effect where polarization of bonded atom will occur due to difference in their electronegativity. This is how we can define inductive effect, and inductive effect is denoted by capital I. One thing we have to understand that inductive effect operate through chain. Before that, if we try to focus a simple compound, that is methyl chloride, where electrons are moving through bond towards chlorine, and we already discussed in our earlier videos. In this case, electron will spare more time around the chlorine, and chlorine will have negative charge and bond is not broken down, so we will show that by using partial charges. So this particular phenomena, when we say it operates through chain, means if to this halogen, say for example chlorine which is there, if we have more number of groups attached in chain, say for example one more carbon is there, so you try to visualize here CH2, CH2, CH2 and CH3. So though terminal CH3 is not being attached to a chlorine directly, but still this terminal CH3 also will become slightly electron deficient, not as the one which is directly linked to chlorine. And this particular phenomena is called as, or this particular fact is called as inductive effect. It occurs through chain. So once carbon which is become linked to electron withdrawing chlorine directly, it has become electron deficient. So in order to stabilize, it will withdraw electron from the nearby carbon. As a consequence of that, immediately next carbon which is become attached will become deficient, and subsequently positive charge or deficiencies among the carbon will go on increasing. So if distance of carbon will increase from electron withdrawing group, then last carbon or last element will become less deficient in the electron. So we can say inductive effect, it operates through chain, but it becomes weakened through the chain when the distance from the electron withdrawing group become increases. And most importantly, this effect is permanent effect, hence chemical properties of the molecule are being affected. Now we'll see there are two kinds, that is minus I effect and plus I effect, depending upon electron releasing nature of electron releasing or group. If the electronegative atom is joined to a chain of carbon, the positive charge is relayed on the carbon. So this particular case is the one where electron are being released from the withdrawn from the carbon. This is electron withdrawing inductive effect. So some other electronegative atom, it withdraws electron from the carbon, whereas in plus I effect or positive inductive effect, this is a electron releasing effect. Alternatively, or we can discriminate these two, minus I is electron withdrawing effect, whereas plus I is electron releasing effect. And here electron releasing groups, most commonly alkyl group, are become attached to a carbon, and when they release electron on the carbon, so alkyl group releasing electron on the carbon, it is called as a positive inductive effect. This is electron releasing character and is indicated by plus I effect. So that is what the basic difference, electron releasing and electron withdrawing, and based upon that this particular effect is categorized as minus I and plus I effect. Example is there. So minus I effect, these groups will always withdraw electron. These are electron withdrawing group, they are highly electronegative. Their order is there, NO2 is greater than F, F is greater than chlorine, chlorine is greater than bromine, bromine is greater than iodine, and iodine is better electron withdrawing or more electronegative than OH, and OH is better than alkoxy. Whereas here this is tertiary methyl carbon, which is greater in releasing electron than the secondary carbon, where two methyl groups are become attached, and secondary carbon is better in releasing electron than the primary, where only one alkyl group is there than the methyl group. So now we will discuss applications of inductive effect. So inductive effect is helpful in understanding certain facts, that is we can understand why carboxylic acids are acidic in the nature by using inductive effect. We can use inductive effect in comparing the acidic strength of different acids. So if more than two acids are there with us, we can compare their acidic strength just by looking at their structure and by applying inductive effect. So we'll see how it is in this case. So if we try to learn first, or we'll try to revise our learning about the acids. So according to Arrhenius concepts of acid and base, acids are the one which has a tendency to donate the proton in the aqueous medium. So inductive effect is useful for giving explanation why carboxylic acid ionize to give the hydrogen ions. So this tendency of losing proton is we can learn with the help of inductive effect. Now this is a generalized structure of carboxylic acid, and we'll see how things are there. So lone pair of electron is there on the two lone pairs of electrons are there on the oxygen. Now we'll see what happening in the carbonyl group. So carbonyl carbon is electron deficient, as oxygen has got more electronegativity. It is the one which will withdraw bonded pair of electron towards itself. As a consequence of that, this carbon become electron deficient. Now as it is electron deficient, it is in need of electron, and lone pair of electron which is there on the oxygen coordinate its electron so that double bond will appear on the adjacent with the adjacent carbon. So one bond is broken down, migration of electron is indicated by arrow. So unshared pair of electron is there on oxygen, and now oxygen become unstable, but carbon has formed to double bond with oxygen, so this oxygen is also unstable. This is unstable in different manner than the one which is there. It is unstable due to excess of electron, this oxygen, whereas unstable due to deficiency of electron. Now this oxygen is in need of electron. So what it will do, there are two possibilities. In order to stabilize itself, this oxygen will either take back its electron from the carbon, and we will get back this structure. One more possibility is there, that oxygen is more electronegative than hydrogen, so it will try to take bonded pair of electron towards itself. As a consequence of that, what will happen? Bond between O and H will broken down. So this is an inductive effect. Inductive pool of electron is there. Now because of that, O become unstable and it acquires a negative charge, and H also become unstable. It departs, leaving electron pair behind on the oxygen, because oxygen is electronegative, and it is being furnished in the medium. Now it is so donated because we define acids according to RNA's concept, species which donates H plus in the water. So water is there, so lone pair of electrons which are there on oxygen of a water will share that lone pair of electron with hydrogen, so that water will become protonated, that is in the form of H3O plus, and so released H plus will be accepted. It become partly stabilized, comparatively more stabilized, and that's why it is being become donated. Otherwise if we do not add water, this carboxylic acid will not behave as an acid. So carboxylate ions are formed by the inductive effect. We have learned that inductive effect is operative over here, and that is why. So I'll try to jot down what I am trying to convince. Acids are proton donor, and proton from the carboxylic acid become donated due to inductive effect of O, and bond between OH is broken down by means of inductive effect. But another fact is there, that is the resonance effect. It's not only inductive effect, it makes H free, but it is the resonance effect which operate between this carboxylate ion that stabilize due to resonance. Stabilization of carboxylate ion occurs. As a consequence of that, H becomes free from the acid. Now same thing we can compare in case of alcohol. So ROH, there also inductive pool of electrons will be there, H will become free, but alkoxy ions which are formed will not become stabilized by resonance. So alkoxy ion will again combine with H plus to form alcohol. So that's why alcohol is not acidic, whereas carboxylic acids are acidic in the nature, and their acidity is because of inductive effect, that is the one which is responsible for breakdown of OH bond, and it is a resonance effect that stabilizes the carboxylate ion. So positively charged oxygen attracts the electron pair of OH bond, that is inductive effect. It removes the H as a proton, and carboxylic acid, CS stands for short abbreviation I have used, therefore it acts as an acid. Now by using inductive effect, we will try to solve this. There are two acids, that is acetic acid and monoiodoacetic acid. Now difference in these two is only a matter of iodine, which I mark with the help of yellow color. Now we have to compare which one is more acidic. Now we have learned we can predict acidic strength of acids by using inductive effect. So we have learned now why carboxylic acid is acidic in the nature. Now we have to compare acidic strength of two acids. Now acidic strength means, like I will revise learning, acids are the species which donates proton. Now strong acid is the one which donates proton fastly. Weak acid is the one which donates proton in slow manner. Now this fast and slow donation of proton depends upon the stability of carboxylate ion. Any factor which will stabilize the carboxylate ion more will make that acid strong. Any factor which will destabilize the carboxylate ion will make that acidic less or weak acid. So in this case, the one which will produce more stable carboxylate ion will be a strong acid. We will learn the fact that inductive effect operates through chain. Now I just resolve this structure. We just wrote ionization of this. So try to understand. Ionization of monoiodo acetic acid is there. H has become free and carboxylate ions are formed. Now, so this is a carboxylate ion where this particular portion is rich in electron. So these electrons, they are located or they become delocalized from this oxygen to this via carbon. So here, so always migration of electrons will be there between two oxygen via carbon. Now fact is that iodine is there, which will show minus I inductive effect, which will withdraw electron from this carbon. So this carbon, which is linked to carboxylate ion, will become destabilized, that is electron deficient, and it is less electronegative than iodine, so it will never withdraw electron from the iodine, rather it will start withdrawing electron from this carbon. And this carboxylate carbon, which is a part of carboxylate ion, will give happily electrons because this carboxylate portion is already unstable because of excess of electron. So when this carbon, which is linked to iodine, when it pulls electron from the carboxylate ion, actually it is stabilizing the carboxylate ion. And I already made mention, any factor which will stabilize the carboxylate ion will make the carboxylate ion more stable, will make that particular acid as a strong acid. So inductive effect of I will stabilize carboxylate ion. So stable the carboxylate ion, faster it will form and acid will become strong acid. So in between these two, monoiodic acetic acid will be a strong acid than the acetic acid. So simple, iodine will withdraw electron from the carboxylate ion. It will decrease the electron density around the oxygen atoms, both the oxygen atoms which are part of carboxylate ion. So rather it will stabilize the carboxylate ion. Now stability of carboxylate ion, I hope now we won't require more time to understand what is that factor which will stabilize the carboxylate ion. So carboxylate ions are unstable. First thing, we have to understand that fact, and their instability is because of excess of electron. So I have shown actually a hybrid of this. So dotted line indicates delocalization of pi electrons from one oxygen to other via this carbon, and they are rich in electron, negative charge, unstable. So in order to stabilize, dispersal of negative charge is necessary, and when electron withdrawing group, so W is any group which is become attached to carboxylate ion. So when electron withdrawing group become attached to carboxylate ion, it will withdraw excess of electron, so dispersal of negative charge will be there, and apparently it will decrease the negative charge of carboxylate ion and it will stabilize the carboxylate ions. Whereas if electron releasing group is become attached to carboxylate ion, it will release electron on the carboxylate ion, say for example methyl group and or any other suitable alkyl group. It will destabilize the carboxylate ions by intensification of negative charge. So in general, when electron withdrawing groups are attached to carboxylate ion, it will stabilize carboxylate ion and that particular acid will become strong acid, it will fast form. Now we'll again do comparison between 2-chloroacetic acid and 4-chloroacetic acid. So we already learned that inductive effect operates through chain. Here 2-chloroacetic acid, chlorine is little closer to carboxylate ion than the chlorine of 4-chlorobutanoic acid. I'm sorry, I read this as acetic acid. So these are 2-chlorobutanoic acid and 4-chlorobutanoic acid. So 4-chlorobutanoic acid, chlorine is quite apart from carboxylate ion, though inductive effect is operated through chain. I have shown this via the movement of electron via the bond. So what happens is, in case of 2-chlorobutanoic acid, here what happens is, this thing, it will withdraw electrons strongly as it is close to carboxylate ion, carboxyl group. So it will stabilize the carboxylate ion in a better manner than that of 4-chlorobutanoic acid. So in case of basic strength of amines,